3D bioprinting is the process of directly depositing material to create a tissue or organ from scratch. My name is Scott Slimmer. I'm the lab manager in Jennifer Lewis's research group at Harvard University and the Wyss Institute.
By being able to directly print functional tissues, one could have, I think, a much more substantive approach to both pharmaceutical drug screening as well as tissue engineering. And that's what our group is trying to do.
The biggest challenge in 3D bioprinting is arguably creating complex vasculature. Vasculature is essential because it supports and pervades human tissue, and without it, cells in the bulk of a structure will die. Cells have metabolic needs. They consume nutrients, they produce waste, and you have to be able to deliver fresh nutrients once those cells exhaust the nearby supply, and you also have to be able to wash away the waste so it doesn't accumulate and suffocate the cells. We've developed a new Fugitive ink that allows you to print a three-dimensional object, encapsulate it with a cell-laden hydrogel, and then just by simply cooling, you can liquefy the Fugitive ink and then wash it away.
The Fugitive ink we used was a pluronic. Pluronic's a very unique material in that it has an atypical thermal transition. At higher temperatures, it's a gel, and at lower temperatures, it liquefies. So what we can do is print at room temperature. First, we print our pluronic network that's going to become the vasculature. At room temperature, it's solid and it maintains its shape. Then over that, we can pour our matrix, our gelatin methacrylate. And at room temperature, it's liquid-like, so it pours over and encases the printed pluronic very well. We can take that entire structure then and cool it down. Two things happen as it's cooling down. First, the gelatin matrix goes from liquid-like to solid-like. At the same time, the pluronic goes from solid-like to liquid-like. We can apply a light vacuum to the end of the pluronic network and simply remove the liquid pluronic, and that leaves empty channels within our solid matrix that we can infill with cells to begin to form our vascular network.
We're interested in basically taking our skills in materials assembly and three-dimensional printing and ink designs and bringing it to bear on this important and growing field.